All right, so we're going to take a look at that, right? Um, right. It's functions. Now, in terms of functions, since I then quite mentioned that we have subcategories, right? But I think maybe the general idea of working with functions is the same. To say we need to know domain, we need to know the range, right? We need to know the y-intercepts, the x-intercepts, but most importantly, we need to be able to recognize the type of function you're working with, right? And some of the, the nitty-gritties that come with it. Now, this one is exponential function, and we do know that in terms of an exponential function, if I can give you a background, um, if your exponential function is like this, let me just say if it's like this, remember that this is the general formula for an exponential function, whereby remember p is the shifting left and right, q shifting up and down, a is very important. A tells you whether the function is increasing or whether the function is decreasing, right? So if it is decreasing, this is when a no, sorry, I meant to say b, ne? B, not a. B. Now if b is between 1 and -1, it means the function is decreasing. But b, if it is greater than 1 or if it is less than 1, less than -1, then the function is increasing, right? And then what do we mean by that? If let's say b is equal to 3/4, I like to say this statement just means that something is a proper fraction, whether that fraction is negative or positive. As long as b is a proper fraction, the graph will be decreasing. So once you see your b like this, it means the graph is decreasing like that, right? Because we move from left to right, you can check that the graph is decreasing. But if it is like this, it means b is either greater than 1 or b is less than -1. Ne? Yeah, examples could be maybe b is equal to 2, b is equal to 4, or b is equal to 5/2. Do you see that it's a fraction, but it's an improper fraction, right? So for the fact that it's an improper, that graph should be increasing there. While a tells you about a, in most cases, in all functions, it will always tell you about the reflection about the x-axis. Yeah, the reflection about the x-axis. This means then it flips the normal graph that you are used to. For example, if you are used to an exponential function like this, if a is negative, this is only when a is positive. If a is negative, it flips that graph like that. If you are used to a normal parabola like this, it is only there because a is positive. Once a becomes negative, that graph will become like this. It flips it. You see, if you are used if you are used to a sine function that is like this, right? If you are used to a sine function that is like this, then you must know that once this is only when a is positive. Once a becomes negative, that function will become like this. So a will always flip your functions, be it it's a what or what. A will always flip those functions there. Let me okay, let me just try to remove them. Okay, so that is what we are saying there in terms of that. Okay, so we must know what a does, what q does and stuff, because it then assists us to work with the questions that we'll be faced with, right? So if a is a fraction, then that is what's happening. So now here we have 14.1. It says write down the range of G. Well, when you look at G there, B is a fraction, a proper fraction. Now that tells you that that graph, it should be like this, right? This will be the graph of G because our B is a proper fraction, so the graph is decreasing. So when you look at the range, the Y values, right? Range says where do your Y values start, right? So you can write 14.1 as follows. You can say Y values are all greater than 0 because there is no Y value that is less than 0. The graph is not on the bottom part of the x-axis, right? Or you could say, right, Y is an element. My Y values, they start from 0 all the way to positive infinity. And don't include this one because remember, in this case, the x-axis acts as the asymptote. The graph does not touch the x-axis, right? So it acts as an asymptote. So you don't include 0 there. Is that clear? Any question?
I just get that one.
Okay. And then for 14.2, right, it says determine the range of the inverse of G, right? All right. Now the inverse of G, in terms of exponential functions, right? We do know that we have two types, right? If your graph is increasing like this, right, the inverse will become like this, right? That will become the inverse. However, so if this is f, this will be the inverse. However, if the graph is already decreasing like this, right, the inverse would then be like this, right? So this would be f, and then this will be the inverse of f. Okay, so that's what we will have. Now this one, since it's decreasing, it means the inverse, if I can try to draw it using a different color there, means the inverse would be looking like this, and the inverse is always the log function, right? Always the log function, whereby here it casts the graphs into the same. You are saying?
I just realized it was log. That's why me swapping it didn't work out.
Oh, okay. Yes. I'm glad you are able to realize that then. So, yeah, the range will not change. It will still say, wait, ne? We usually say the domain of the original function is the range of the inverse. And then the range of the original function is the domain of the inverse. So in this case, what would be the domain of what would be the domain of, okay, let's check. The domain of the original one. And here we have the range, right? What would be the domain? What would you say is the domain of G?
Negative infinity to positive infinity.
Right, so it means x is an element of real numbers. Now this tells us that, okay, this tells us that this graph, I should draw it properly, right? Like this. I should draw it properly there. So it means that this graph should be looking like this. Right? Yeah. Should be like this. Yeah, nice stuff. Right, so now the range, what will be the range of the inverse, right? So it means the range of the inverse is going to say y is an element of real numbers, meaning from negative infinity to positive infinity. I always say, if you are looking for the domain or the range of the inverse, this is what you do, right? Look for the original. Just make sure you work on the original. The original says that the range is y is greater than 0, while the domain is while the domain is x is an element from negative infinity to positive infinity. Now I need you to know that in terms of the inverse, in terms of the inverse, when you are looking for the range, it will be the domain of the original, meaning you just change this x, you write it as y, to say y is an element from negative infinity to positive infinity. While for the domain, right, you just look at the range of the original and then you just change this to what? You change it to x is greater than 0. All you do is just to look at, if you're looking for the range, look at the domain. If you're looking for the domain, look at the range. They're always the opposite. Then you change accordingly. Are we clear? Right. And then now for 14.3, it says, is the graph of the inverse of g a function? Justify your answer. Is it a function?
Yes.
It is a function, right? Great stuff. Yes. So our answer should actually be yes, it's a function. Why? This is because
It passes the vertical line test.
yes, it passes the vertical line test. That's true. It passes the vertical line test, right? Or you could say for each value of x, there is one corresponding value of, there is only one corresponding value of y. Okay, 14.4 then says, right, we have a point here which is ma is to 2. It lies on the inverse, right? Calculate the value of a. Quite an interesting question, right? Now I always say again, when they give you stuff on the inverse, do not worry. You just have to take that inverse, convert it back to the original. Okay, on the inverse, you have a point which is m, which is a is to 2. On the original, the very same point will just be the very same point whereby you swap x and y, meaning it will just be looking like this, isn't it? So this means on the original, you already have x. Since this is x, then you would be looking for y. So you can simply use the equation given to say g of 2 is equal to half to the power of 2, right? Because x is 2. Where I see x, I just put 2, right? Or if you don't want to write it like this, you can simply say y is equal to half to the power of 2, right? Where you see x, you put 2. So the answer would be 1/4, isn't it? Perfect, which means that the point will be, so here we usually put this to say it's not the same, as the original. So it means the inverse would be 2 and 1/4. Therefore, it means a is equal to 1/4. Are we clear then? Right, so these are some of the things we need to just remind ourselves, especially I know they like it, the exponential, right? So those are the things that we should make sure that we are always looking out for, right? Now I do have another question here. Let me just do this. Yeah, so this is the question here, quite also an interesting one that I saw. Think it was from Eastern Cape or so. And then let me do this. What does it say there? It gives you a sketch of 2 graphs. Yeah, so this is the graph of f and the graph of g and the x-intercept there, right? Should we work through it? Sorry?
Please, if you don't mind.
Okay, no problem. I just wanted to check something here. For that we, oh yeah, nice, okay, no problem. Yeah, so we find a question like this, right? The first thing we should do is to recognize the two functions we have. This is f there, right? And then g is there, right? Then we have g there. Now we are given the turning point already, ne? Now they want the coordinates of b. What is b? When you look at b, right, it's a point that is lying on the x-axis. So this tells you that b is a what? Is an x-intercept, right? Right, since b is an x-intercept, already you must write the coordinates to say, oh, okay, it means b there is an x, but we do not know y. No, y is 0, but we do not know the value of x. Right, now the question now is, how do I find x? Well, b lies on which graphs? B lies on f, and also b lies on g, right? So because it also lies on g and we have the full equation of g, we can just use g to get the coordinates for 5.1 to then say, since g of x is equal to negative x plus 5, x value is, we don't know, right? But the y value is 0, so you can just say 0 is equals to negative x plus 5. Taking x this side, you get x is 5. Therefore we have the coordinates of b as 5 and 0, right? So now I quickly update there. I quickly update that b is 5 and 0. Then once I have this, right, I then go to 5.2, right? 5.2 says determine the equation of f in the form of y is equal to ax squared plus bx plus c. Now, there are two ways of finding the equation of a parabola, which also works in the similar way to a cubic function. Now, to find the equation, there are two main cases, right? Case number one, you could be given the x-intercepts, the two x-intercepts. In the case of a cubic, you could be given the 3x-intercepts or the 2. Once you have that, I need you to write the following: y is equals to a into x minus x1, x minus x2. Please, you already go to this formula. If it's a cubic function, you will put x minus x3. Okay, like I told you that I'll try to just integrate all the functions, right? So in this case, it's a parabola. You would go to this. Case number 2, if you are given a turning point, a turning point, which is also called a stationary point, it's also called a stationary point, right? So if you are given a turning point or stationary point and one other point, be it a y-intercept or x-intercept, right? Then immediately you need to then, for a parabola, you immediately write the formula here: a into x plus p all squared plus q. This is the one you use. In the case of a cubic function, you would immediately find the derivative. But even here you can actually do that. I don't know, I'm tempted to show you in terms of derivative. Mara, you know what? Let's go along with this one, right? So which case are we talking about here?
Definitely the second one.
Perfect, definitely the second one. So we are using this formula, Now, we then say, okay, y is equals to a into x. Just look at the x value of the turning point, Just change its sign when you put it here. Just write it as negative. If it was positive, you write it as negative. If it was negative, you write it as positive, Then I just need you to look at the y coordinate of the turning point. It's 49 over 4, ne? Just
I
right.
can't really see. It's a bit too small.
It's a bit too small, I skis. It's actually here t 3 over 2 and 49 over 4. Okay?
Okay. Yeah.
Right, so here it's 49 over 4. That one you don't change its sign. Alright?
Yes.
You're okay. Now the last thing to do is just to substitute that given point, that any other point given. In this case it's b. And get. So where we see x we put 5, where we see y we put 0. 0, and then on x we put 5. Put 5, right? And then we say plus 49 over 4. Great. Now please assist me with the calculator. I will take the negative 49 over 4 this side. Now what does this give you? 5 minus 3 over 2 all squared. Or maybe let me write it again. Let me write it again so that we can divide by it and just work on the calculator once. 5 minus 3 over 2 all squared. Right. Now can you put this in the calculator? Please use brackets. Ne?
I got -1.
You got -1.
Yes.
Wow, nice. Therefore, this means that y is equal to -1 into x minus 3 over 2 all squared plus 49 over 4. However, did we answer the question? Did we get the equation in the way they wanted? No, right? Because the other form that they wanted, it's actually y is equal to ax squared plus bx plus c, ne? Right. So that is the one that we're going to strive to get there. So how would we get that form?
I think we'd have to expand with the one that you got right now.
Right, we need to expand it, right? Just want us to do a little bit of more work unnecessarily, but then it's fine, we can do it, ne? So we then say so we're going to expand this and say y is equal to negative, and then okay, let's say x minus 3 over 2 plus 49 over 4, because it's squared there. Okay, so we say x times x, we get x squared. X times that is -3 over 2x. This times that is -3 over 2x. And then we have plus 9 over 4. To say this times that is 9 over 4. And then plus 49 over 4. Let me remove this. Right. And then, yeah, we can say x squared minus 3 over 2 should be minus 6 over 2, which is minus 3. And then plus 9 over 4, right, plus 49 over 4. Then we multiply inside with a negative, right? Negative x squared plus 3x minus 9 over 4 plus 49 over 4. Now please put these two in the calculator. Positive 10.
Yes.
Great, so that is 10, right? So that is the equation of f there, right? In this form it actually looks much nicer than with fractions there, right? And then now Oh, look at the next question. This the next question says if f of x is this. You see they gave you and it looks like the one you got, right? But let's just say you couldn't solve 5.2, or let's just say by any by some like some reason, for some reason you are not able to solve 5.2. You are allowed to use to continue with the answer they gave you on 5.3. You are allowed to use it. You see, you can't say, I didn't get 5.2, let me just leave 5.3. No, you should actually use 5.3 as it is. In fact, if I was you, I would go to 5.2 and actually write f as this. If they give me a mark, they give me. If they don't, they don't. Right? Right. And then you say, they says calculate the coordinates of S. Now you ask yourself, what is that S? What type of point is S? You see, if we can check all the time, I ask myself, what type of point is this? The other one, you said it was an x-intercept. This one, what type of point is that?
It's an intersection of the two graphs.
Is an intersection. So it tells you already that we need to solve simultaneously, ne? Yeah, but to make things easy for us, right, for 5.3 there, let's remember that g of x was equal to negative x plus 5, and then our f of x is equal to negative x squared plus 3x plus 10. So what we can simply do is to equate the two, because at s they share the same y value. So we're gonna say g of x is equal to f of x. Then we'll say negative x plus 5 will be equal to negative x squared plus 3x plus 10. Leave 0 there. Or you could do this, take the negative x squared to this side, then this becomes a negative 3x minus 10 minus x plus 5. Okay, so I took everything to the left. Then from there we have x squared minus 3x minus 1x is minus 4x, minus 10 plus 5 is minus 5. Then you can use the quadratic formula and what do we call it? The quadratic formula, right? Or you could simply factorize. So you'll say I need minus 4, so I should have minus 5 and then plus 1. So therefore x will be negative 1 or your x will be 5. However, why are we getting two x coordinates? Two x values. What does it mean?
Isn't the... I'm not sure actually.
Look at the answers. Look at them. And then look at the graph.
If it has two x-intercepts.
Close. No, it's actually because we have 2 points where the graphs are intersecting.
Oh, okay.
Yes, we have 2 points. Now that's why we get the x values of them. This first one is negative 1 and 5. So for 5 we already know that it's at B, ne? It means that S is what?
5.
Therefore at S, no, x should be negative 1, ne?
Oh, yeah, okay.
Because this one is for B. Okay, you can check the graph. That one is for B there. Open.
Yeah.
Perfect. Now that we got the x coordinated S, we can just use either f of x or g of x to get the corresponding y value, right? So I'm just going to use g because it looks much easier. So we just say g of negative 1, meaning when we see x we put negative 1, and then we have that, which means it's 1 plus 5, which is 6. Therefore s will be negative 1 and 6. Right, then I write it, right? I do not waste any time. As I'm getting coordinates, I'm writing. Now there comes the last part, which always talks about you mapping, we call that mapping, right? Or rather locating, or rather interpreting. Use the graph to solve for x where f is greater or equal to g, right? So where is that? F is greater or equal to g, meaning where f is above g. You understand me? And where is f above g here, right? Can we agree that from here all the way to here f is above g?
Yeah, from -1 to 5, around there.
Aha, so it's from -1 because here is -1. So it's from x is an element from -1 to 5. And mind you, I'm using square brackets because they said or equal to. Anger, they said or equal to. That's why I'm using square brackets. If they had just said where is f of x greater than g of x, then I would use round brackets here like this. Okay. All right. And then the last question here. What is that question saying here? It says x squared plus 3x minus that is less than 0. Which graph is that now?
F, maybe?
Well, for f we have negative x squared plus 3x plus 10, right? While this one, it is negative x squared plus 3x minus 2 over minus 2 1 over 4, ne? Yeah. So where would be that? Well, we can see definitely that it relates to f. However, how can we get negative 2 1 over 4? Can you just say for me, ne? Can you say okay, we can say 10 minus q, just use q, ne? 10 minus q is equal to negative 2 1 over 4, ne? Then you will say negative q is equals to negative 2 1 over 4 minus 10, right? So can you put that in the calculator for me and tell me what you get? Negative 2 1 over 4 minus 10.